Okay guys, our lesson today is to be able to find the perimeter of a composite figure. A composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Here are two examples. First we have this figure here, right? It's composed of a square and a triangle. But we're looking for the perimeter of that figure, and the perimeter of that figure would be this outside distance that I'm tracing with the pen. Alright, so we would need three sides of the square to find the perimeter of the figure and one side of the triangle. Alright, we also have this figure here that's made up of semicircle and a rectangle, but the perimeter of the figure would be this distance around here. Right, the perimeter is the distance around the outside of the figure. Alright, to find the perimeter of a composite figure, we find the distance around the figure. Next page. So first we want to be able to estimate perimeter using grid paper. Right, when we estimate the perimeter, we first count the number of grid square lengths around the arrow. Right, here there are 20 of them. And what do we mean by grid square lengths? Right, this is a square length. Right, this one little distance here, that's one square length. So we want to count how many of those do we have for the circumference, or the perimeter of the figure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's where we get that 20, grid square lengths from. But also we have this distance here. And these distances are diagonal distances, so they're a little bit more than one square length. If we're estimating, we would estimate the diagonal distances at 1.5 units. So how many of those diagonal distances are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 of those diagonal distances. So if we're finding the perimeter is going to be equal to 20 of the grid square lengths plus 1.5 times 8, because there are 8 of those diagonal distances. 1.5 times 8 is 12, so the perimeter is going to be equal to the 20 plus the 12, so the perimeter is going to be equal to 32, and they would just be units, right? 32 units would be the perimeter of that figure. All right? Let's try another one. A couple more. All right, and remember, the grid square lengths we're going to count as 1. The diagonal lengths we're going to count as 1.5. So let's start with our grid square lengths. How many of them do we have? We have 1, 2, 3, 4, 5, 6, 7. There are 8 of them there. All right, did I count that? 1, 2, 3. Nope, counted that incorrectly. I believe there were 7. 1, 2, 3, 4, 5, 6. Yes, there are 7. Then there'd be 7 here. 1, 2, 3, 4, 5, 6, 7 grid square lengths there. Then we have the diagonal distances. And how many of them do we have? 1, 2, 3, 4, 5, 6. So we have 3 there, 3 there. 1, 2, 3. And 1, 2, 3 here. So if we're finding the perimeter, we have 7 plus 7, so we have 14 of the grid square lengths plus 1.5 for each of the diagonal lengths, and the diagonal lengths there are 3, 6, 9, 12 of the diagonal lengths. So if we're trying to find or approximating the perimeter, 14 plus 1.5 times 12. 14 plus 1.5 times 12 would be 18. So the perimeter would be 14 plus the 18. So for problem 1, the perimeter would be about 32 units. Right? About 32 units. Okay, let's look at our next one. Let's start with our grid square lengths first. 1, 2, 3, 4, 5. There's 5 there. 1, 2, 3, 4, 5, 6, 7. There's 8. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 units there. So for the grid square lengths, those are either horizontal or vertical lengths, we have 5 plus 10 is 15. 15 plus 8, let's see, we have 5 plus 8 is 13, and 10. That's going to be 23 up, but I almost forgot these. 1, 2, all right. Close that. All right, we have 1, 2, 3. So we have 3 of them. So that's going to be 26 of the grid square lengths. Plus the diagonal distances are 1, 2, 3, 4, 5 of the diagonal distances, and each of those diagonal distances are 1.5. So I have 26 plus 1.5 times 5. So that's 26 plus 7.5. So that's going to be a perimeter of about 33.5 units for the perimeter. About 33.5. Okay, let's continue down here. All right, we want to estimate this perimeter here. We start with our grid square lengths first. There's 1 grid square length, 2, 3, 4, 5, 6. All right, so there's 4, 1, and 1 here. That's going to be 4, 1, and 1 here. So we have 6 and 6. So we have 12 grid square lengths plus the diagonal distances. So we have 1, 2, 3, 4, 5, 6. Oops. And these are 7, 8. Right, so these are all 2s. But we have 1.5 times, right, there's 8 of them. 1.5 times 8 is 12. So we have 12 plus the 12. So the perimeter is about 24 units when we're estimating the perimeter. And we say about because we don't know this exact distance here, right? That's something that you guys will learn a little bit later as an 8th grader. So we're approximating those distances. So about 24 units for the perimeter. Okay, let's take a look at our next example. I want to be able to find the perimeter of this figure. The perimeter of this figure is made up of the semicircular part here, and then the 2 segments that make up the triangle, this segment and this segment here. Well, the segments for the triangle, we know their exact distances. This is 6 units, or 6 feet, and this is 8 feet. But we don't know this distance here, which represents half the circumference of a circle with a diameter of 10 feet. So if we're looking for the perimeter of that figure, we have to first find the circumference of the circle with a diameter of 10 and take half. So circumference divided by 2 is going to be equal to pi times the diameter divided by 2, which is going to be 3.14 times the diameter of 10. But then we have to divide that by 2. That's going to be 31.4 divided by 2. So that's going to be about 15.7 feet. But to find the perimeter, we still have to add the legs of the triangle. So the perimeter is going to be equal to the 8 plus the 6 plus the 15.7 feet. 8 plus 6 is 14 plus 15.7. So that perimeter is going to be equal to 29.7 feet. All right. Let's look at some more examples. It says the running track is made up of a rectangle and 2 semicircles. Find the perimeter. Semicircular ends of the track form a circle with a radius of 32 meters. Find its circumference. So let's start with the circumference of a circle, which is going to be pi times the diameter. So circumference is going to be equal to 3.14. Now, if the radius is 32, means this diameter here is going to be 64. So that's going to be pi times 64. And if we multiply, let's see, circumference is going to be equal to, all right, so that's going to be, all right? So pi times 64. Let's break out the calculator here for a second. All right, so that's going to be 3.14 times 64. Circumference is going to be 200.96. So those are meters. Now that's just the circumference of the circular part. But we still need, let's see, to find the perimeter. I need this distance here plus this distance here, which is another 200. So that's going to be 200 plus another 200. So the perimeter is going to be equal to 400.96, and those are going to be meters, right? That's going to be our perimeter, 400.96 meters. All right? Okay. Let's continue. Next problem. It says the figure is made up of a semicircle, circle, and a triangle. Find its perimeter. Okay. Well, once again, similar to the other example we did, we know this distance here, and we know this distance here, right? Those two distances we know. But we still have to find the half the distance around the circle with a diameter of 26. So let's do that. We need the circumference divided by 2. Circumference is going to be pi times the diameter, but we only need half of it, so we divide it by 2. Pi is going to be 3.14, and the diameter is this distance here. That's going to be 26. But because we only have half of the circle, we're going to divide that by 2. When we multiply 3.14 times 26 and then divide that by 2, we wind up with 40.82, and those are centimeters. But to find the perimeter, I still have to add, let me show you, this 10 plus the 24, so I still have to add the 34 units, and we wind up with 74.82, and those are centimeters, and that's going to be what my perimeter is going to be equal to. All right. Next example, similar to the track problem. All right, I have to find the circumference of these two semicircles, and when we put two semicircles together, they form a whole circle. Well, what's the diameter of that circle? Well, the diameter of that circle is going to be equal to this segment here, and because this is a square, all of those segments are going to be the same. So that's going to be 8 meters. So we start by finding the circumference, which is going to be pi times the diameter. So the circumference is going to be 3.14 times the diameter, that's 8. So circumference is going to be 3.14 times 8. That's going to be 25.2. But then we still have to add, to find the perimeter, this distance of 8 meters plus this distance of 8 meters. So we have to add that distance of 16 meters. So when we add 25.2 and 16, that's going to give us 41.2, and those are meters for the perimeter of that figure. All right? Well, let's continue. We go to our last group of problems, and what do we have? We got another 5 here. Some are easier, some are a little tougher. You guys can certainly try these on your own if you want, and then stop the video and then come back and check how to do them, or go ahead, follow the video and just do the problems as I do them. All right, we're looking for the perimeter. I have this semicircular part here, so that is the circumference of half of a circle. All right, and the diameter of that circle is going to be the same as the side of the square, so that's going to be 5. So we need the circumference divided by 2, which is going to be pi times the diameter divided by 2. We're going to use 3.14 for pi. The diameter is going to be 5, but we need half of that distance. So when we multiply 3.14 times 5, and then we divide that by 2, we wind up with 7.75 for the circumference divided by 2, and those are meters. But we need to now find or add these three sides of 5. So I have a 5 meters plus 5 meters plus 5 meters to complete that perimeter. That's going to be another 15 meters. So when we add those 15 meters, we wind up with 22.75, right? And those are going to be meters. And that's going to be our perimeter. All right. Now this next problem is a lot easier because we don't have the semicircle or a circular region, so we just have to be careful with these segments here. So to find the perimeter, I need this distance of 14 feet, which we already know. I need this distance of 12.5 feet, which we already know. I need this distance of 4 feet, which we already know, and this distance of 5.5 feet, which we already know. But we don't know this entire distance here, and we have to find that. Well, this distance here is going to be the sum of this 14 segment plus this 5.5 segment. So 5 plus 5 plus 14 means that that segment is 19.5, and those are feet. We also need this segment here. And this segment here is going to be the difference between 12.5 take away 4. Right? So what's 12.5 take away 4? That's going to be 8.5 feet for that segment there. And now the perimeter is simply the sum of all of those segments. So we have 4 plus 14 plus 12.5 plus 19.5 plus 8.5 plus 5.5. We add all of those segments together, and the perimeter is going to be equal to 64, and those would be feet for that second problem. Right, this next one, we know this segment here is 4, this segment here is 7, this segment here is 5, this segment here is 3, but we're missing this piece here. But this piece here is going to be the same as that piece there, so that's 7 centimeters as well. So the perimeter is simply going to be equal to 7 plus 5 plus 3 plus 7 plus 4. So that's going to be a perimeter of 26, and those are centimeters. All right. Now this next example, we have 7 yards here plus 1 yard. And then we need, let's see, this segment here, which we don't know, but that's going to be 7 take away 2. So this is going to be 5 yards for that segment. We also need this segment here, which is going to be 6 plus the 1. So that's going to be 7 yards there. And then we just want to add everything together. So the perimeter is going to be equal to 1 plus 7 plus 7 plus 2 plus 6 plus the 5. We add all of that together, and we get a perimeter of 28, and those are yards. All right, and then our last example here, we have the two semicircles, and two semicircles, when we put them together, give us the circumference of an entire circle whose diameter is 14 feet. So we start with that. Circumference is going to be pi times the diameter. So circumference is going to be 3.14 times the diameter, which is 14 feet. So the circumference is going to be equal to, what's that, 43.96. Those are feet. But we still need the 7-foot segment plus this 7-foot segment for the entire perimeter. So that's another 14 to find the perimeter. So the perimeter is going to be equal to 43.96 plus 14. That's going to be 57.96, and those are feet. All right, so just remember, when we're finding perimeter of composite figures, we have to find the distance around that entire figure. And that may mean sometimes using the formula for the circumference of a circle, or using half of that formula if we're looking for the circumference of a semicircular region. All right, you guys do your best with your problems, and I hope that that's been helpful. All right, we will see you soon.